This is a tiny gear cut into a stone cliff, and if you let it mesh with a giant gear 100 times larger, then every time the small gear spins 10 turns, the big gear turns just once. Now take those two gears, lock them on the same axis, copy this setup 100 times, and let every small gear bite into the next large gear. Congratulations! You've just invented the Google gear. Now comes the part that feels almost unreal. When the very first gear spins 10,000 turns, the second gear turns 1,000 times, the third turns 100 times, and by the time you reach the fifth gear, it only turns once. If you want that final gear to complete a single full rotation, the very first gear must spin 10 to the power of 100 times. That's a 1 followed by 100 zeros. Let's slow this madness down and put time on it. Assume the first gear takes 3.5 seconds to turn once, then the third gear needs 350 seconds for a single rotation. The fifth gear needs 10 hours. The 12th gear needs 11,000 years. The 16th gear needs 110 million years. And by the 18th gear, one rotation takes 11 billion years. This is the raw power of exponential growth. So you might wonder, what if we drive the first gear using the speed of light? Light travels at 300,000 kilometers per second. That's equivalent to spinning the first gear about 281 times per minute. At that speed, the 12th gear completes a turn in just 4 minutes. The 21st gear needs 6,980 years, and the 30th gear needs 6.9 trillion years. For comparison, the entire universe has only existed for about 13.8 billion years. This device is terrifyingly powerful, because even if you used all the energy in the universe, starting from the moment the universe was born, you can only make the 27th gear rotate twice. So can we just turn the final gear directly? The answer is no, you can't even move it. If turning the first gear requires only 5 pounds of force, then turning the 100th gear would require 5 pounds multiplied by 10 to the power of 100. Even if a superhero showed up, it still wouldn't work.